now have Jakob Sandel Sorrenson, and he's going to live stream. So, welcome, Jakob. Thank you.
Thank you. Thank you for having me. My name is Jakob Sandel Sorrenson, as you correctly said. I'm a landscape architect, and I am also the head of sustainability at the landscape architecture and planning firm Schønherr in Denmark. I'm streaming in from our office in Copenhagen. It's now 10 to 11 Thursday evening in Denmark. So, and this is weirding me out a bit, but good morning to you all. I hope you've had an enjoyable first day. I'm going to be talking to you today about, I'll just see if I can share my screen, about circular economy, or rather about the role of landscape architects and landscape architecture in the transition to a future circular economy. Now, I'm going to be showing you some examples of what we are working with in Denmark, both in the context of the Danish Association of Landscape Architects, but also in my own work as head of sustainability at our office. Some of it is a work in progress, so I hope you bear with me. Some of this presentation is going to be quite text heavy and uncommonly under-illustrated for an architectural presentation. This is because it's a dynamic document, actually. I'm still working on it, and I hope that you will all give me as much feedback as possible. I have quite a lot of slides to get through in 30 minutes, so I'm going to start very shortly. But because of those reasons, I've added my email address to the final slide, and I would encourage any of you to contact me afterwards if you want a copy of the presentation. If you have any feedback or any reactions, I would be more than happy to interact with you. Okay, circular economy. What's that about? Well, basically, this is it. This is what it's about. Everything that we have ever built, everything that we have ever extracted and modified or produced in order to build these things, everything that we have ever torn down or demolished, turned into waste or pollution, if you like, it's all here. It's all still here. Where else could it go? So this is it, and this is all there is. We only have one of these. So what's the problem? Well, the problem is that right now we are using more than one of these. We are using quite significantly more than one planet a year. On average, right now, we are using about 1.6 Earths a year. Or rather, if you imagine the global biocapacity or the ability of the natural systems to regenerate themselves, if you imagine that as a budget and you distribute that budget equally among all the countries in the world, this diagram shows you the date of the year, the time of the year on which individual countries exceed their share of the yearly budget. So, as I said, on average right now we are using about 1.6 Earths, but that's not an average. Some of us are using far more than that. I'm ashamed to say that we in Denmark are using more than you are in New Zealand. In fact, we exceeded our yearly budget on March the 26th already. if we compare it to you, you will reach your limit on actually a week from now, on next Friday, May the 15th. So if everyone were to live like we do in Denmark, we would not need just 1.6 Earths, we would need more than 4 Earths a year. So clearly, the way that we are doing things now is, they're not sustainable. This can't go on. We have to find another way of doing things. And if we look at our own industry, the construction industry in Denmark right now, the construction industry is responsible for about 30% of all emissions, all yearly emissions. So about 30% of the energy consumption as well, but also about 30% of all waste is generated by the construction industry. So the responsibility that we have, or I guess you might say the potential that we have to do better, is actually quite significant. Almost a third of all emissions and all waste generated comes from the construction industry, at least in Denmark. I'm pretty sure that the numbers are quite similar in your part of the world. I'm not actually sure exactly what they are, but there is a huge potential to do better. So what we've been trying to find a way of doing in Denmark is to describe principles that are more sustainable, that are in principle circular. So what is a circular economy? Well, it's restorative, it's regenerative by design, and it aims to keep products, components, and materials at their highest utility and value at all times. So, in other words, it's an economy which doesn't extract or pollute more than the natural systems can sustain. It's a system, an economic system in balance with nature. In the bottom left corner, you can see the front page of the first edition of a guide to circular economy for landscape architecture that we did in the Danish Association of Landscape Architects. It was published a little more than a year ago. We are currently working on the second edition, which will include a number of examples of case studies of projects, which we are using to demonstrate these 4 principles of circular design or circular methodology that we have developed for this guide. Actually, I say we have developed them, but that's not entirely true. They are not our invention. They were developed originally by an organization called the Ellen MacArthur Foundation. I'm sure some of you have heard of this institution. They are doing and have been doing quite a lot of groundbreaking work on circular principles and circular economy the past many years now. These 4 principles were originally developed targeting, let's say, more traditional production industry or production companies. So companies taking natural raw material or resources and turning them into products in order to sell, to move on, sell on. We have tried to translate these principles into something that we can use as landscape architects, something that is understandable and relevant in the construction industry. So let me take you through these 4 principles quickly. First of all, we talk of the inner circle. So this is the principle that the less change you need to apply to a site or to parts of a site, or the less you need to change or to refurbish a structure or a material to reuse it, the higher the potential savings are. Or you might say the lower the environmental impact is. So some of the keys to the inner circle are, for instance, retaining existing parts of the site or the project as is, preserving plantings, leaving soil or sub or base layers untouched, or perhaps even keeping entire paved areas as they already are on site. This principle is called the inner circle. Another principle is called long-term circulation. This is about the durability of a structure or a material. If you can, through maintenance or replacement of individual parts, if you can extend the lifetime of structures or materials, it's referred to as long-term circulation. So designing and building constructions in a way that allows for easy maintenance and or for replacement of individual materials or parts of that structure is long-term circulation. Also, using durable materials makes it possible to imagine that these can be reused either on site or in new projects elsewhere in the future. So keeping already produced building materials in circulation for as long as possible. That's this principle, long-term circulation. The third principle is cascaded use. This refers to the process of redesigning or refurbishing existing materials or parts of structures, and thereby extending their lifetime or making it possible to reuse them as parts in new projects. Again, the object is to keep materials in circulation and avoid the extraction or minimize the extraction of new virgin material resources, and thereby lowering the environmental footprint. It's all about lowering the environmental footprint and using as few resources as possible, actually natural resources as possible. The fourth circular principle is called pure circles, and this refers to attempting to retain the purity or quality of construction material. If we can design in ways that allow us to deconstruct or to disassemble these structures in the original parts and original pure parts, it's easier to reuse materials than if they've been mixed or processed in some way. So this has to do. This has a lot to do with how we design. Actually, a lot of the decisions that we make as designers in the design phase are crucial to the degree of recyclability or degree of reusability of structures or individual materials. If we can design in ways that allow or retain the purity of these materials, they actually often have a higher resale value. Some of them even increase in value over time. If you imagine natural stone pavings, for instance, some of them become more valuable and more beautiful over time, and the resale value is actually increased if you can deconstruct the pavings when they are decommissioned on one site and they can be reused elsewhere. So these four circles are what we are using as a way of describing, let's say, the level of sustainability or the level of circularity in, to begin with, Danish landscape architecture projects. We are working on a second edition and also a translation into English. So hopefully within a couple of months we will issue this second version. I'll be happy to mail it to you or make it available to you if anyone's interested. And hopefully this collection of examples will grow over time and serve as an inspiration to others interested in trying to decrease the footprints of the projects that we do, trying to systematically document that we are doing things in more sustainable ways than maybe we used to do. So that was a bit about the work that we have been doing so far in the Danish Association of Landscape Architects. But I'm also working on developing a set of guidelines, I guess you might say, or a list of focus points or questions, if you like, that we can use ourselves in this office when we design, when we develop our own projects, when we talk about our projects, when we interact with collaborators or clients. So a series of good advice, you might say. And I'm going to take you through that list. I may have to move a bit quickly, but let's see. So this is this illustration is an attempt to illustrate what we are doing right now or have been doing historically. We've been thinking in linear processes. We've been imagining that we could do whatever we want to begin with. We've been imagining that we start with an empty slate, a site with nothing on it, and we can just build whatever we want. We can use it for as long as we like. We can change it when we want. We can demolish and dispose of it when we need to do something else, when we want to do something else. So this linear model is quite resource heavy. It requires a lot of new raw materials, a lot of new products all the time, but it also generates a lot of waste all the time. Like I said, in Denmark, about 30% of all new materials and all new energy input is used in the construction industry. But also about 30% of the waste generated every year comes from our industry. So the potential for change is actually very significant. What we need to do, of course, in order to find a better balanced model is to change this linear thinking into a circular thinking. We need to stop generating as much waste. We need to stop extracting as much natural resources, raw materials that we do right now. So the series of good advice that I'm going to take you through now is built on this model, on this circular way of planning or thinking about the lifetime of our projects. But not only our projects, also the projects that came before us on the sites that we work on, and the projects that are going to replace our projects on the same site when we are done. So Again, the object is to keep materials and products in circulation for as long as possible. Why? Because generally the problem that we have as a species, as humans, is that we exert too much pressure on the rest of nature. We are taking up too much space, we are extracting too many natural resources, and we are polluting and generating too much waste. And many of the problems that we are facing right now, actually, like climate change and the horrific loss of biology, of life, of biodiversity that we see across the globe. Also, some would argue the global pandemic that we are living through right now. All of these problems are actually symptoms, and the underlying reason is the way that we as a species live our lives, the way that we exert too much pressure on the rest of the natural world. So everything we can do to lower that impact will also automatically lessen the problems, the other problems that we are facing right now. That's why we are focusing so much on let's say, the environmental part of sustainability. I know sustainability is much more than just environmental issues, but these are the issues that have impact on a global scale. If we do whatever we can to minimize our environmental footprint, we can focus on problems that are basically only human problems afterwards. So I'm going to run through this now, and as I said, it's quite a text-heavy presentation. This, I apologize. I'm going to be doing quite a lot of reading. If you had a few drinks last night, I understand if you zoom out. No worries. I'm going to speak up and try to keep you awake through this. Okay. So when we take over, when we start a new job, when we analyze a new site in order to create a new project, what are some of the good advice that we need to do in order to think more circularly, in order to be more sustainable? Well, first of all, we need to identify any elements worth keeping or worth preserving. Most sites contain values, inherent values, local qualities, which, if we can protect and preserve them, we can pass them on as future value. So understanding what is already there and what is worth keeping is one of the keys to minimizing the need for new construction materials and new energy input. Often some of these elements are easily preserved, some of them often cost very little to protect and keep on site. But this is of course also a planning issue. So before we even start planning or designing, we need to identify the values on site already. At another scale, we need to identify if the site already contains construction materials or elements that we can preserve or with little or no processing reuse on site or locally. The cheapest materials are those that are already on site. So if we can reuse them, we reduce the need for new materials to be extracted. And also we can, as Kirsty said, we can do what landscape architects like to do. We can embed the history or the narrative, that we like to call it, of the history of a site in its future in a very understandable and direct way, simply by reusing the materials that are already there on site and have been used on site previously. We need to understand, now much of this is I guess, basic or common knowledge to us as landscape architects already, but remember that we are thinking about this in terms of sustainability, in terms of circularity. So we need to keep doing what we already do, but we need to understand why we're doing it. We're not just doing it in order to create the best project for us. We are doing it in order to preserve the qualities of the site. We need to understand the terrain, we need to understand the soil, we need to understand the physical and chemical composition of the soil. We need to understand microclimatic conditions. Every site is different, so we need to understand, we need to have a profound understanding of what's going on these locations, on this individual location. Because this is the basis of finding the best solution, the balanced synthesis to best accommodate the future use of this site. But also we need to think about the context. We need to zoom out a little bit. We need to understand the surroundings of a future site or a future project. Everywhere is connected to its surroundings. So, and the value of many places actually depend on these connections. So we need to understand what connections are in place already and what connections could be created or enhanced, improved, because this adds to the sum of the already existing qualities in the area. We need to stop trying to compete with what's already there. We need to add what's missing to add to the sum of the quality of an area larger than our own project site. We need to understand, as I said, we need to understand what's lacking, what's missing. And we need to see how we can improve on that. So a good project should always seek to add new qualities to an area, not just to a site, but to a larger area within which the site is located. Qualities that are in demand locally or have been lacking. Some projects, all of our projects begin with a claim that something is missing. We need to build this highway. We need to build a new office building, whatever. Only some of our projects are generous enough or holistic enough to actually understand and identify what's already good and functioning and working in the area at the same time, and not attempt to compete with that, but attempt to add new qualities and add to the sum of the region instead. So when we have that understanding of a site, we start designing. And when we design, there are also things that we can do to limit our footprint. First of all, we should always try to minimize paved areas and to maximize planted areas. Why? Well, because pavings are the parts of our projects that have the largest environmental footprints. They require a lot of materials, they require a lot of energy input for extraction of and transportation of materials, for construction and maintenance of these pavings and surfaces. Whereas plantings are actually storing carbon. They are actually restoring nature. They're cheaper, but they also add to biodiversity. They counteract some of the negative effects that we see, in particular in urban areas. The phenomenon known as urban heat island effect. Plants, through evaporation, through shade, help minimize these problems. Plantings purify rainwater and help restore natural hydrology. So plantings in general are much better than paved areas. Now this is of course a question of how do we compose our design? How do we compose our layout? Often when we work with building architects, we need to plan our pavings, but the pavings are also are dependent on how many entrances there are to a building. Where are these entrances placed in relation to each other? Do we access this building from a car park or from bicycle parking? Or so all of these connections that we create from the surroundings to our site and on our site are crucial. The composition of these paving of these components are crucial to minimize the paved areas and maximize the plant. We need to build with the terrain and not against it. So understanding the topography of the site and always attempting to design, create a design seeking soil balance. Now this is easier said than done because soil is many things. Soil is composed of many different materials, and generally if these materials or these soils are disturbed or mixed, the quality of the soil degrades. So the larger the areas in which soil can be kept intact, the better. And good soil management actually ensures better physical connections, both above and also importantly below ground. Natural hydrology, the ability of plants to take root, and so forth. The less that we can disturb soil, the better. Again, we need to plan for the reuse of materials. If there are reusable materials already on site, we need to create a design to keep them on site. Preferably keep them as they are, where they are, but otherwise by refurbishment or redesign, include them in the future product, future project. Sorry. Remember that also plant waste is reusable. We can use that as fertilizer or growth accelerator for new plantings and for local biodiversity boost. We need to plan for low maintenance and we need to plan for long durability. Often we tend to overlook the operational phase or the user phase of a project as landscape architects. We tend to think of ourselves as designers, and when the construction is done, our work is done. But we need to understand that this design, if we are to be as sustainable as possible, we need to make sure that this design lives on as long as possible. We need to design for long life. So if we adapt a design to the resources and maybe in particular the capabilities available for later maintenance of the site, the chances of success are greater. So we cannot design elaborate plantings if the people that are going to maintain these plantings are not qualified to do so. We need to adapt our design to the available resources and the available capabilities of the site in the operational phase. Again, we need to include new features that are lacking from the local area. We should always see any project as an opportunity to add to the sum of qualities, not just compete with those already in the local area. If we do that, it's more likely that the project will be appreciated and be used and kept for a long time. So it's quite obvious, really. And when designing in detail, or when designing for construction, there are also a few principles that are important. First of all, we need to design for disassembly. We need to make sure that the construction parts that we design are designed to be easily disassembled or easily maintained, because this ensures that the individual materials can be made available for recycling or for reuse when we are done with them. This also means that we should try, whenever possible, to avoid assembling methods such as casting or welding or gluing, and try to replace them with mechanical solutions or using gravity or physics in order to keep our structures in place. Try to avoid mixing or polluting materials in any way if we can. Designing for disassembly is important. Also minimizing the need for surface treatments or painting. Some of the materials or many of the materials or surfaces that we expose to the weather in our projects are put under stress from moisture, from acidity, or from sunlight. But some of the methods that we use in order to protect the degradation of the use or the wear and tear of those surfaces are actually quite harmful processes, environmentally harmful processes. So we should try to minimize that if we can. Instead, we should be careful when choosing the materials. We should be careful. We should try to design for keep a focus on what are the layers of the structures or constructions. What are the thicknesses of the individual materials? Can we add a bit of thickness and thereby gain a bit of life, or avoid having to surface powder coat or surface treat to protect those materials. That's a better and more sustainable solution. Also, that will prevent us from polluting these materials and making them, degrading them, making them less recyclable. We should, whenever possible, use unbound pavings and substructures. Bound pavings are difficult to disassemble and to reuse. Often the materials are significantly degraded. They need to be crushed in order to be reused. So if we can construct them as unbound pavings, it's much easier to deconstruct and reuse as individual materials again. If possible, we should choose local or regional materials. Several benefits are associated with this. First of all, we of course minimize the energy required for transportation. We also allow ourselves an easier way of monitoring critical production issues. It's easier to oversee the production of construction materials if it doesn't take place on the other side of the world. But also the likelihood of correctly assessing the properties of these materials and crucially also preserving these properties over time are actually greater if the materials come from at least the same climate zone, if not local, or if not a region as the project is to be built in. Natural stone from the other part of from the other side of the planet. We don't really know how that is going to behave in 30 or 50 or 100 years if we use that locally. So using local materials, regional materials, is desirable whenever possible. We should design simple structures that can be repaired. If we design structures using as few materials as possible, joining them using simple or standardized methods, it's easier to maintain. And it's more likely that the structure will be repaired and not completely replaced. Also, if we build from standardized products in standard or regular formats, the likelihood of this happening is even greater. So, what am I saying? Am I trying to stop us from doing special designs or customized designs? No, I'm just saying that perhaps we should focus our customized designs to areas or sites or parts of sites where it's really important, and try to use more standardized methods and products whenever possible, because these are easily replaced if necessary. When we start building, we need to plan the construction process. Quite a significant part of the share of the waste that we produce in the construction industry is actually a result of poor or inadequate plan of the construction process itself. So if we plan or help plan the time and resources spent in the construction, during construction, the risk of wasting resources is low. Again, when we build and construct on site, we need to take care to protect whatever structures or elements that we have preserved from earlier. The more value that we have, that we've deemed these structures to have, the better the protective measures be. So the greater the value, the more comprehensive and effective the protective measures need to be. I'll try to move quickly through the last of the slides here. We need to minimize solid waste for recycling. Also, critically, we need to hand over critical information to the future owners, future users of the site. A lot of the knowledge that we build up when we design projects is actually lost when the projects shift owners or the future users of the projects take over. We need to plan that maintenance, but also crucially, we need to adjust these goals as we go along. Landscape projects are living entities, and the use of them change over time. So we need to change the maintenance plan as well. We need to make sure that the people maintaining our projects have the right skills to maintain it. It's very easy to destroy parts of a landscape project if you don't know what you do. We need to keep high standards. We need to set good examples, inspire our neighbors to do the same. We need to, if possible, include and activate users in the maintenance. We need to reuse whatever we can locally on site. When we dismantle and try to recirculate this, we need to protect whatever is worth protecting for the future. We need to dismantle and store elements so that it can be reused. We need to process materials and store them for reuse on site, preferably if possible. And crucially, we need to dispose of as little as possible. We need to minimize waste. So, in conclusion, we need to do whatever we can to design out waste and pollution. We need to keep products and materials in use as long as possible, and we need to do whatever we can to regenerate the natural systems. Thank you for your time.